Hi everyone, I would like to show you this simple web app created in Python using Streamlit. It uses an invented retail dataset to build a machine learning model that can be used to predict several features, including the distribution of areas inside the store, construction costs, and future sales revenue, presenting at the end an economic analysis of the inversion. This is a basic example of what could be a useful tool for expansion, taking advantage of all the accumulated data within organizations. If you want to know more about the dataset used, you can click this plus button on the corner to expand this section. I have created a whole dataset with 600 rows and 15 columns of an hypothetical retail company with surfaces, construction costs, and sales records. To create it, I have multiplied the features by several invented rates, and I have added some noise to each value to make them slightly different. Below you can see the first 10 rows. The method used to create a dataset is a succession of correlated linear regressions, and for the model I'm using a multi-output regressor chain. I have here some evaluation metrics of the model. I haven't worked on the model to improve performance. This is what I got from the raw data. As you can see, the R-square, or coefficient of determination, that goes from 0 to 1, being 1 the best result, is quite high. A real dataset will have to be processed before you could use it, filtering and cleaning the data and also normalizing it in order to be able to compare it. The records will need to be classified by the type of store, if needed. Also, construction costs will have to be updated to the current year by the accumulated inflation rates of different construction years. And finally, if you are comparing stores in different countries or areas with different price levels, you can normalize it by using different metrics, as the purchasing power parity index. Okay, now that we have seen the data and the model that runs under the hood, let's see the app and what it's capable of doing. You can input the characteristics of your store, for this example, just 2 of them, and get a prediction. In this column, you can find the estimated surfaces that you need for your store. That information can be sent later to the design team as a requirement before starting with the store's project. Also, you are getting the construction estimated cost in this column with the estimation of different works that you can find in the construction of a store inside an existing building. I have added the possibility to add some inflation rates in case the prices are increasing or expected to increase as currently. Under this, you can define the scope of works. This will be useful in case of reform, as there will be works that won't be needed, and also some of them maybe would be done just partially, as you can keep some of the existing elements. Everything is 100% by default. That means it's all new. If you want to make some adjustments, for example, I will set demolitions to 0, as there is no demolition in the project, and also facilities to 50%, as we can reuse some of the existing on the building, and the prices will automatically update. In this column, you have the estimated sales revenue and some donut charts with the percentage of the surfaces and the cost. Once you have all your prediction numbers, you can go for the next section to continue with the analysis of the inversion. You can add some parameters in the first column, the annual rent, the annual labor cost, other annual cost, the period in years that you want to study, and a discount rate. Also, the user has the opportunity to modify the construction cost and the sales revenue. It works like a manual override, and this is handy as there are some parameters that you don't have in your dataset but can be very important to the final output. For example, a construction work, not a standard, that has to be done in the location, or a modifier in the sales as there are more competitors in that area. Once that you have completed, you can generate automatically a report getting some financial metrics in this column, like the return of investment, net present value, internal rate of return, break-even point, and also some graphics like the profit and loss statement, and also the CAPEX and OPEX percentage. I invite you to give it a try, and if you like it, you can follow me in LinkedIn.